So first and foremost, we are not actually going to be using the mics or anything today. Let me share. Let me get on camera here. There we go. But we will be using a Kahoot quiz. And so the number to join is above me. And at the end of each section, we're going to have a couple of questions for the schools. And basically, when those sections come up, we're going to jump onto the Kahoot quiz and go through some of the details then. And essentially, what we'll do is I will wait till I see some of you join there, just so I know that you've got that set up already. So I'll give you a minute or two to kind of get that started and get that signed up. Perfect. I can see lots of you jumping in, which is a great start. That means you're all hearing me and everything's going as well as it should be. So for now. So yeah, if you need me to share this pin again going throughout the presentation, if you've missed it or anything, then just let me know and I can share it again. But for now, I will move forward because I think I've got 20 or so participants in my quiz so far. Oh, and it's going up now, which is great. So yeah, keep your mics off because we will be recording today's session and we'll be recording it just so we can share it with people that weren't able to make it live today. And so when the recording's done, we will share it around with everyone. And hopefully some of you have been to the previous sessions. If you've been to the previous sessions, then let me know, give me a thumbs up in the chat. And I'll know how many of you know some of the knowledge already there, basically. So yeah. Oh, I could see some thumbs up already, which is a good start. I'm glad some of you have been before. Now, I have on call as well with me my colleague Megan, who you will all know as your main contact for the Spring Bulbs project so far. And Megan is there waving. Say hello, Meg.
Hi, everyone. I'm hoping you can hear me properly.
We can hear you properly, definitely.
Amazing.
At least I can. And some of you wanted to put a face to the name that you've been communicating with the last couple of months. So there is Megan. And she's going to be taking far more of a central role next week's session. But for this week, she's going to be the unfortunate person that I get to fire questions at, basically. So yeah, so whenever we get a Kahoot question, we're going to be firing them at her as well. So yeah, I will call you back on, Meg, when we're ready with the questions, so make sure you were listening.
Mm-hmm.
Good. So we will get underway then. So what we are going to be looking at today is we're going to be going on from last week's session mainly. And what we were doing, not last week, in the sessions in January, and we were looking at the Spring Bulbs project and the impact of the Spring Bulbs project, but actually focusing on art and botany and things like that and the scientific side of artist creation. And we did a bit of a paint along session. But this session and next week's session, we're going to be focusing on the climate change emergency. And what we mean by that is we're going to go through what climate change is, what humans did to start it. And being in Wales, I'm kind of perfectly placed to talk about what we did to start it, but we'll get to that in a second. And we will be looking at kind of how we generate our energy and our electricity and things like that. And then finally, we're going to look at the Spring Bulbs project overall and the information that's been gathered over the 20 years. Because some of you may know or may not know that this is the 20th anniversary of the Spring Bulbs project. And over that time, we've been able to gather an amazing amount of information. And so we're going to showcase how that looks and what we've learned from the scientific experiments that all of you have done over the decades now. But first and foremost, we'll start with what is climate change, which some of you may understand, and hopefully some of you do understand a lot about, but we're going to go through the basics. So climate change is probably something you might have heard of before, but what it generally means is a long-term global change to temperatures and weather patterns. Now, climate change is caused by a buildup of what we call greenhouse gases and in Earth's atmosphere, and these prevent energy being reflected back into space, essentially. And so the Earth's temperature rises and it leads to all manner of different problems. So CO2 is a big contributor, which we will get to at the moment now. But some of the changes that we're likely to see with rising greenhouse gases are, rising temperatures, sea levels rising, more extreme weather, loss of wildlife. And when I say loss of wildlife, that's anything a bit, that's plant life, that's animal life, that's sea life, it's all across the world, really. Now, in the past, while the wildlife climate change has happened massively in the past, but normally it's been because of natural factors like the volcanoes, for example, or like the ice age, or some sort of natural event or occurrence that has changed the environment of the world massively. Now, how now there is a much bigger dangerous. If you think the volcanoes are dangerous, then these are much more dangerous. People, humans, far more dangerous than any volcano in any way, shape, or form. Now, humans and their actions have been affecting climate change drastically. And in the last 200 years, um, most of the climate change has been directly because of human activity. And it directly because we have been burning fossil fuels. Now, what that means essentially is we are changing the world far quicker than natural forces or anything has ever done before, really. But first and foremost, as well, what is a fossil fuel? So, can any of you in the chat let me know of what a fossil fuel name? So, name a fossil fuel essentially in the chat and let me know what fossil fuels you can name. Coal, that's Danielle in the background, but there she's my little assistant on the computer in the background checking the chat. Coal, oil, perfect. And there's another one, a third major one which we want. We got coal and oil. Perfect. So you've got all three, coal, oil, and gas. Now, oil, coal, gas. Now, these three are fossil fuels. So these are fuels that have been developed over millions of years deep beneath the planet's surface. And what they are is they are extremely good fuels. So they burn really well and produce lots of energy. But the problem is, even though they might all look the same, they actually all put out into the atmosphere one of the most dangerous things in the greenhouse gases category, and that is CO2. So even though that all of these fuels look different, they all produce massive amounts of CO2. Now, CO2 is in fact the most abundant of all gases. And I should say as well, coal out of the three fossil fuels is the dirtiest of all the fossil fuels, the most polluting of all of them, really. And it's one of the ones that we're going to be focusing on today mainly. This is a bit of a pie chart of the greenhouse gases. So this is a chart of what makes up greenhouse gases. And as you can see, there's some gases here, like, nitrous oxide and methane gas in there, but carbon dioxide makes up nearly 80% to more or less 80% of the greenhouse gases. And again, when we look at what we've been burning and producing over the years, that the reason why that is will become quite clear, hopefully. So the best way I've always think about this is if you think about greenhouse gases as a huge blanket that covers the entire Earth. So this blanket is made up of gases, not fabric, but gases. And now and again, this blanket allows stuff to go back into space, allows heat to escape naturally. But the more carbon dioxide we add into the atmosphere, the thicker that blanket gets. And that blanket loves to absorb heat, but it doesn't let heat go. So the more carbon dioxide that comes in, the more that gets trapped here, and the whole planet begins to heat up in a massive way. So here's another question for you that I want you to answer in the chat. Do you think Britain will get hotter or wetter if climate change continues as it is now? So will it get hotter or wetter if climate change continues? What do you think? Both from Mountain Lane. Nice. Wetter, hotter. Any others? More hotter. Now, generally, a lot of people will say hotter, but hotter doesn't mean necessarily that it wouldn't be wetter, because how the weather systems of the Earth work is they're very well balanced, and certain things can change them quite drastically. So, for instance, the hotter times of the year will eventually bring more heat waves. So, those of you in the chat that said both, you're quite right, because the heat will also bring more rainfall and more flooding, because hotter weather and hotter air retains more water, and so it holds on to more moisture and then releases that moisture over different parts of the world. So yeah, what it will get hotter and it will get wetter, both. So those of you thinking the climate change is an amazing thing that'll bring sunny events and sunny summers to Wales are very wrong. If anything, it'll get much more incredibly wet here. Carbon dioxide now, more than any other point in human history, is higher. This is a graph from NASA. Now, NASA are the people with far more knowledge on this, on space and the environment than me. And they created this graph, and that dotted line in the center shows the levels of carbon dioxide in the atmosphere. And as you can see, there's a bit of a tipping point there. Over hundreds of thousands of years, carbon dioxide hasn't taken over, hasn't risen above that line. But as you can see now, at about 1911, it reached that line and went even higher and still continues to this day. And what we're going to find out is why that line is being breached. What has happened to push that over the edge? But before we do, we're going to go to the Kahoot. So hopefully you've been listening, and I'm going to start the Kahoot now for you to see in your classrooms, hopefully. And I will share my Kahoot screen now with you, and hopefully you will be able to see it. Let me share my Kahoot screen with you now. And hopefully you've been listening. Hopefully. Now we're going to get started with our Kahoot. You've all done this before, I'm sure. So make sure that you know the answer. And the first question is, which is the dirtiest fossil fuel? The answers there are gas, coal, oil, and they are all clean. Meg, what do you think?
It's quite a tricky one, I think, because all of the fossil fuels could be considered dirty in many different ways.
So
But I went for coal.
Perfect. I'm glad. That's a good start. Because if you didn't, we would be very upset with you, particularly being in Wales, where we are known for coal, really.
Absolutely.
Now, most of you got that right. So 43 of you got that right. And so we'll go on to the next question now. And hopefully some more of you will get that right. Flying clam is the leader so far. That's the one to beat. So what percentage of greenhouse gases is made up of carbon dioxide, Meg? What do you think? 50%, 60%, 70%, or 80%?
Well, I remember you saying it was quite a high percentage of carbon dioxide. That was one of the bigger ones. So I think I'm going to go for 80.
And let's see what
We'll
everyone else
see.
goes for. 80, 69% of you, 69 of you got that right, which is good. Let's see
Amazing.
who's in the lead. Well done, Meg. You are, in
Thank
fact,
you.
listening to me, which is a great start. Thank you. So let's see if flying clam has been pushed off the top. Fuzzy McCaw is now leading.
Well
So Fuzzy
done.
McCaw is the one to beat. But anyway, let us get back to the presentation. So let me just share over screens for you. So, and actually make me pop out as well. Give me 1 second. And there we go. Hopefully you can see me fine. So, how did this all start? So this is a long answer, but hopefully you will get a lot because it's a complex answer as well. Being in Wales, we are kind of perfectly placed to talk about how climate change started and how Britain contributed massively to climate change as well. So this picture behind me is Wales before what we call industrialization. So this was before all of these vast collieries and coal works and ironworks and all these different big industrial things came into place. It was mainly a rural area. So what type of jobs do you think was going on in Wales at this point? If you drop it in the chat, what type of jobs do you think were in Wales at this point? So hopefully you will have said farmers, because farming and farming stock were the main ways of working in Wales at this point. And so if we look back at, say, the 1700s, there were many, many things happening that changed Wales and would bring about massive changes to how we work and how we live. A cannon now. Going from farmers to a cannon might seem like a bit of a change, but in the 1700s, there were many, many wars around the world, and more metal was needed to create weapons like cannons. So to make metals like iron that was made of cannons, you would need to heat up iron ore using coal and other materials in a large furnace. And I'll give you an idea of that furnace now. So this is the type of thing you would use. We call it a blast furnace. But that doesn't matter so much as how it's being powered and fueled. So we would use it to heat up ore to over 1200 degrees, and it would melt the iron stone and cool, and you would begin to have iron to make cannons and guns. Now, for many, many years, wood was used as a fuel for these furnaces, or not just in Britain and in Wales, all around the world. But it wasn't the best fuel to make iron in this way. Coal was seen as a much better fuel because it burned hotter and for longer. And so they started using coal in furnaces like this around Wales to make iron and copper. And so heating up to 1200 degrees in these furnace, you would dump the coal in the top, dump the iron stone in the top, and then by the time it gets to the bottom, you would have the raw materials. Now, where I come from is a place called Merthyr Tydfil in South Wales. Now, Merthyr Tydfil was mainly a farming place before around 1750. Then a few English industrialists came in and they saw an opportunity to earn money by making weapons. And so they turned Merthyr into an industrial town. They opened 4 ironworks in Merthyr Tydfil altogether. But when they opened these ironworks to make this metal, they needed to open coal mines as well because the furnaces would not work without the fuel to power them. And so many coal mines were opened. And this was the first big push in Britain to mine coal from under the ground. They would be mining it to power the furnaces to basically smelt iron and copper. By 1790, Merthyr Tydfil was the iron-making capital of the world, which if you ever go to Merthyr, we will be quick to tell you this all the time. But it was being used, vast amounts of coal were being used in the furnaces. So for example, okay, in 1850, one ironworks in Merthyr Tydfil would burn around 300,000 tons of coal every year. So there were 4 ironworks in Merthyr Tydfil, and all 4 would burn collectively over 1.2 million tons worth of coal every single year. And that's just in Merthyr Tydfil. That's literally just in Merthyr Tydfil and nowhere else at all. Because when you look at other places as well, the similar things were happening in other places. So if you look at places like Belfast, for example, that was seen as the industrial engine of Ireland and was burning coal for different things. Glasgow, They were making ships. They were fueling steam engines and trains, which we'll get to in a second. Manchester was a fabric making capital of the UK. Newcastle was mining and making metal as well. So all over Britain, we were now using this new type of fuel to make different things, from metal to fabric to all these different things. But it would start to get even worse, believe it or not, because if we look at this image here, okay? So this image here is a very early coal mine in Britain and in Wales specifically. And the thing that always strikes me about this is there's no large engines pulling and pushing anything. What we've got is we've got horses pulling winding gear that is bringing up and down from below ground the coal and the miners. And you can see the coal in lumps here. So this horse is actually the engine, if you want to call it that, to pull people up and to pull coal up from underground. And over in this side of the picture, we can see a water wheel. Now, a water wheel was a bit of technology that was being used by lots of people to power engines. So this is a water wheel that is still in Llanberis up in North Wales, our Slate Museum up in North Wales. And so they would use it to power different machinery. And so it would power different things, and you wouldn't need anything else apart from water power. But that would all change just a couple of years later, because this is now a modern coal mine. There are no horses pulling up and down winding gear here. This is the winding gear here, which is pulling miners and coal from up under the ground. And it is not attached to a horse, it's attached to steam engines. And that's what these are, steam engines. And so the steam engines would slowly replace all this kind of other ways of making stuff. So it would replace horsepower, it would replace, water power. Steam power would be what would be used. And how these steam engines worked is you would basically put coal in here, it would heat up water, and then the steam that's produced from the heating up water would then push and pull different mechanical parts to lift or push or do whatever you wanted, really. And this would really change things massively in every way, shape, and form. It would be such a gigantic game changer. It's unreal. And so the steam engines put us in a position where now we're not only using coal to make a product, we're now using coal to power all the different mechanics that go into that product. So an iron furnace. Initially, iron furnaces, like we saw earlier, were powered by water power. Now they're powered by steam power. But this furnace, for example, would be guzzling up all the coal, but it would also be guzzling up coal to power the steam engine that was pushing cold air into the furnace and stoking it. The woolen industry. At one point, you would have water power turning these gears to turn these mills to make fabric. But now turning these gears was all down to steam power. So now even the woolen industry that was not really using many fossil fuels at all, we're now using massive amount of fossil fuels to make clothing. Transport. Transport now changed drastically. In the early 1800s, people would still be traveling by horse and cart. But by the 1830s and 40s, trains became the biggest method of transportation in the UK. And the thing that powered these steam trains was coal. Coal powering, heating up water, powering the steam into the engines to move the mechanics. Even then, massive ships that were once, powered by wind power and things like that were now powered by steam. Steam power was now everywhere. So much so that by 1911, when we look at that graph, that we saw earlier, the 1911 point that pushed us over the edge, that was when we were using steam and coal for everything. And keep in mind, it's not just Wales. This is happening all over Britain and all over the world. How people lived and how people traveled through the world and how people worked totally changed. And it all relied on burning fossil fuels. So there's lots to get through there. So we're going to jump over to the Kahoot quiz for a second and see how you all fare with that. So give me 1 second and I will get back onto the Kahoot here. If I stop sharing there. And yeah, I see that a lot of you answered farming and blacksmiths. There was some metal making going on, but again, not as much as you would think. Wales really changed into an industrial capital after the 1800s, really, the end of the 1700s, early 18. But nothing really prepared Wales for what would happen by 1911. So, next, I hope you're ready for question 3, Megan.
I am.
How hot does a furnace need to be to melt iron? 1000 degrees, 1100 degrees, 1200 degrees, or 1300 degrees?
They're all very similar, so I'm
They
trying
are.
to remember back to what you said. I think it's 1200.
Perfect. And again, 90 of you got that right. So fair play. You were
Amazing.
all listening attentively because that was a really important fact. Because again, to get up to that heat took an awful lot of coal. It took an awful lot of coal to power that furnace to get up to that level of heat. So well done, guys. Let's see who's in the lead. Fuzzy McCaw is still in the lead with a very nice pancake hat as well. I can see there, which is nice. So yeah, Meg, let's see the next question then.
Yes.
How many tons of coal do the ironworks of Merthyr use every year? 600,000, 800,000, 1 million, or 1.2 million? So this isn't just one ironworks. This is all the ironworks put together.
I'm going to go with 1.2, I think.
You're going to go for 1.2. We will find out. 83 people agree with you, Megan. So well done, well done, well
Amazing.
done. You were doing well. You were doing well.
Thank
And
you.
yeah, it's crazy when you think of that just being one place at one time. And the amount of coal Merthyr would burn in the years after 1850 would even dwarf that figure. It would continue to go up and up and up. It's crazy. But yeah, does anyone in the chat remember how many ironworks were in Merthyr, by the way? For bonus points. Don't answer too quick, Meg. Put it in the chat if you remember.
I'll have to think.
Oh, don't look at the chat, Meg. You're going to get answers. Everyone's doing well so far, though. Well done.
I think we've got quite a common answer here.
I can see you looking at the chat, so I'm not going to take your answer now. You're disqualified from the chat now, officially, okay? Right, so we will get back to the presentation now anyway. And see what differences we can see going forward and what this means for our planet and going forward, really, because even though all this was happening, believe it or not, you could think, oh, it can't possibly get any worse. Surely it can't possibly get any worse than that. Well, you would be wrong in thinking that because it does definitely get worse. Because as the 20th century, so the 1900s move on, we have a different type of fossil fuel usage, which really does ramp everything up massively in a big, big way. So after 1911, we started changing over to a different type of energy for our homes. Because I should have said earlier as well, actually, the coal, even though coal was being used in industry, coal was being used in homes and houses around Britain as well. And so they were using it for all manner of different things to heat the homes. And so it had a massive impact on the pollution of different places where there were lots of people. So London, for example, had massive smog kind of air problems with many people dying in the early 40s and 1950s because of the amount of smog and air pollution in London, and all to do with burning coal. But when we started this century, we started using a different type of energy. That energy would be electricity. Now, if we're using electricity, we think, oh, well, electricity is a really good, clean form of energy. You might think that, but you would be very wrong if you think that, because how you generate electricity is basically, it means, well, it can be good or it can be bad, but how we were generating the electricity in the 20th century was pretty bad. Now, a good example of this, again, comes in Wales, which we will get to. But what would be happening in the same way as the steam engine? I'm moving my head slightly, but this here is coal. So imagine this fire as being the coal. That's the fuel. And above it is the water being turned to steam. Now, instead of this steam engine powering mechanics in a coal mine or in an ironworks, this is actually turning a turbine. So a large fan is turning it very, very fast. So the coal will burn, heat the water, turn to steam, turn the turbine, and that turbine's movement is creating electricity. We generated most of our electricity in the 20th century, even up until very recently, in this way, using coal. This is Aberthaw Power Station in Wales, a very famous power station in Wales, and it's one of many that are around Britain. You will have a similar thing near where you live across Britain, I would imagine, as well. But it's bizarre to think that generating electricity using coal would actually contribute to 96% of all electricity generated in the UK in 1950. So 10 years, so 1950, so you're talking 40 years after we just overtook the most carbon in the atmosphere ever, we are now thinking of even newer and more explosive ways, really, of changing the atmosphere. This would add such a significant amount of carbon into the greenhouse gases mixture in the atmosphere. It is unreal. So even 10 years after that, so even 10 years after this, it was still generating 90%, and it would hold on there for decades, because more and more people needed more and more electric. So the more and more our life changed, and the more and more equipment, the more and more infrastructure was all made by electric, the more and more coal we burned. So even though many of you, and even me, we might have grown up, in houses that didn't burn coal in the fireplace in your homes, but you were still burning thousands of tons of coal just by the electricity you were using, because it wouldn't exist without the burning of the coal. So the Aberthaw Power Station burned coal to generate electricity, but on average, it burned around 5,000 tons of coal every single day. In 2013, so really recently, it burned 3.5 million tons of coal just to generate electricity. And that is just one coal, one factory, generating factory. There were many, many across Britain, and all of them burning millions upon millions of tons worth of coal. So if you remember, the ironworks of Merthyr in 1850 burned 1.2 million in a year. This is burning 3.5 million in a year. So everything is being scaled up massively in a big, big way. And you might not think how bad it's affecting the atmosphere around you. You might overlook the signs of how it's affecting the atmosphere around you. But there are signs everywhere. There's signs in the weather, in the wildlife, and plant life in particular, which is what makes our project, the Springboard project, so important, because plant life is often taken for granted. But the flowers and the woodland are often the areas that first show signs of climate change happening. So, for example, in Wales, we have this beautiful flower. We call her a Snowdon lily. Now, this lily was first discovered in 1696, and it is a flower that likes the cold weather. Even though it was discovered in 1696, it was a bit of a hangover from earlier ice ages. So it's been around for many, many, many years. And because it developed in a colder climate, it likes colder spaces. So it's found mainly on the high hills of Snowdonia, the mountain range in North Wales. But as everything begins to get warmer, the areas where this plant life can live become smaller and smaller. And so now this plant is becoming more and more rare and is on the verge of extinction because the climate is heating up. And that is just one of many, many plants that are currently in danger from climate change. And when you think of endangered species on the world, you might think of, different animals and things like that, but you often don't think of plant life. And they are some of the things that will affect our way of life more than anything, really. Thankfully, though, there is some positivity in all this, and we are moving in a good, solid direction. Because believe it or not, in recent years, we have made massive, massive changes to how we generate electricity, which is a massive thing. Obviously, as many of you growing up in Wales will know, we are not really digging up coal from the ground anymore. It's not really a job. There are no coal mines really in Wales at all. And making metals is very much reduced. So all of that early development and use of coal and fossil fuels has gone down massively. But obviously, electricity still needs to be generated. And so we had to stop using coal to generate it. And this chart from 2024 can show you how things have changed. Now, you can see a big chunk of our energy comes from gas. So whenever any of you are plugging your phone in or plugging your iPad in or whatever, using electricity, one of these things is powering the electricity to come into existence, is generating electricity. So gas is used in the same way coal was, and gas was the dominant way that we generated electricity in recent years. Still not great, because as you remember from earlier, gas is still one of those fossil fuels, and it still produces CO2 emissions when it's burnt. It's less polluting than coal, but it still produces a lot of CO2. But in 2024, for the first year on record, gas came second to a new type of generation, wind. And you can see here a wind turbine. So wind power generation for the first year on record actually contributed more to our generation of electricity in Britain than a fossil fuel, which is a good step forward. But obviously, we need to get this section of the pie chart far bigger than this one. And we can do this by improving things like solar power. And people are often exploring nuclear power as well, which has a lot of other problems as well, but it doesn't produce CO2, but it does cause a lot of other issues as well. Now, the one thing you can see here, which is amazing, is this, the coal. We went, within a 50-year period, we went from 96% essentially of our energy being generated by coal to now less than 0.6%. A massive shift in how we generate electricity, a gigantic change, really. And so, yeah, very much a different world we live in now. But I'm going to give you our final two questions before we explore any changes we can get from our spring bulbs investigation. So give me a sec and I will share the final quotes with you if my computer allows me to. There we go. Okay. Are you ready, Meg?
I am.
Good. So, Fuzzy McCaw still in the lead. Let's see the final two questions here, guys. So if you want to topple Fuzzy McCaw, this is the time to do it. In 1950, how much of the UK's electricity was generated by burning coal? 46%, 96%, 76%, or 36%? Meg.
Oh, here we go. The screen is just loaded for me. Don't know if it was slow for anybody else there.
Oh, it might have been. I'm not sure. We are getting answers
We're
in
okay
anyway.
now. I remember this one because it was quite a scary percentage. So yeah, I went for 96 as well.
Are you sure? Because you answered after you saw the answer, then you might
No,
have been.
no, I did. I
Okay, I'll
promise.
trust you for now. 70 of you got that right, which is great. Again, it's an astounding figure, to be honest. Like literally every kind of electrical item in the UK between the 1960s and 1970s was powered by coal, essentially, not electricity, which is bizarre to think. Yeah, has Fuzzy McCaw been toppled? No, Fuzzy McCaw has not been toppled. Final question to topple Fuzzy. What is the name of this rare flower? Swansea lily, Suffolk lily, Snowdon lily, Salisbury lily. An easy one to end.
Yes, of course. It's the Snowdon lily. That's what
The
I've gone for,
Snowdon lily.
which
Yeah, we're
is
getting
such a
all the
shame.
answers in. We've got all the answers in.
Yeah.
And we'll see if everyone has agreed with that.
It's a shame that these flowers
Yes.
are
110. But yeah, it is a shame. They're beautiful flowers. And again, to think that someone in 1696 stumbled upon it while walking along the mountains of Snowdonia, stumbled upon it, recognized it, and now it's going to be gone. You know, it's not going to exist in the wild. And there are many, many plant hunters out there that spend days on end hunting the mountains around Snowdon to find one. And then they quickly photograph it because they're so, so rare. Like you'd be lucky to see one traveling around there for days on end, to be fair. It's really rare. So there we go. Fuzzy McCoy in first, Fuzzy Goat in second, and Shimmering in third. Nice, nice, nice. Well done. Now, this final bit of the section is all about your work. It's all about the work of spring bulbs. Now, as you know, it's 20 years of spring bulbs, and the project really has gathered masses of information. And let me pop up here actually. Give me a second. My computer is definitely not liking me right this second. Here we go. So yeah, so over the 20 years, we've seen massive changes really. But we leave ourselves looking at the 20 years of spring bulbs thinking, okay, if we look back over all these experiments, what has been the major factors that have changed? So in the experiments, we look at temperatures, we look at flower growth, and those are the two main things that the experiment is kind of gauging. So have the temperatures changed over that kind of period of time? Have they had any major impact that we can see and understand? And so this is the Welsh winter temperatures as monitored from 2006 right the way to now by pupils, by students. And we can see a bit of a trend going on. And what the trend line is showing us is that in Wales, we have got a little warmer since 2006. But the change is small, and there are lots and lots of variations along the way. As you can see here, starting here, there's massive ups, massive downs. So the weather is changing, but in general, there's a bit of an upward trend. This is the variation. And so there is less variation between kind of this point in the graph than this point. So the years since 2018, about here, there's generally been far less of a change, really, and far less variations in the weather, which again shows that the climate is changing in some way. That was just Wales specifically, though. When we look at Britain overall, we get a much, much different idea, a much, much different picture. So this is the UK temperatures from Britain overall. And Britain overall joined the project in 2012, I should say, because it was a Welsh project for many years. But then the Adina Trust jumped on board and we were able to roll out the project right across the UK, really. Here we see there's a similar thing happening, a similar thing going on. This is the variation. And again, we can see that there's a narrowing of the variation. And so what that means is essentially everything is changing, getting less diverse and slightly warmer, but it's little changes. But those little changes will have a massive impact, as we'll see in a second now. So when we study the trends, plant life is a bit different as well. So this graph behind me now is the average flowering dates in Wales for the project. So the trend line going through the center there shows that daffodil flowering has got slightly earlier over the years, but there has been lots and lots of variation. Sometimes these variations can be caused by natural things, I should say, as well. Sometimes they can be caused by a variety of things. But in general, that's what makes the project so important, because we're getting a large amount of information from all you climate scientists in your classrooms. And we were able to kind of put that into some picture to get an understanding. But to get a really good understanding of how everything's changing, we'd have to do another 20 years or more to get a massive, massive picture of how things are changing. So if we look at this one now as well, the average UK flowering dates overall, again, we started this one in 2010. So we see the trend line there shows that the flowering has gotten slightly earlier over the years again. But this one has lots of variations kicking in too. So there's lots of points where the variations will kick in. Crocus. Some of you have been planting crocuses as well as the daffodils. Hopefully all of you have, and hopefully some of you have been enjoying your mystery bulbs as well. So average crocus wet flowering dates in Wales are quite a different story as well. Now, this has a lot to do with weather as well for the crocus, because the crocus kind of in general kind of reacts to sunlight in a far more sensitive way than daffodils. But the trend line, as you can see, is still there. So the line of the graph overall is showing that the crocus is still flowering earlier, but we still having those little variations. So there is still a change. And this again is the UK one. And you can see how strange the line is for crocus. And again, it's because it's a far more delicate plant that's affected far more easily by the environment around it. But the trend line can see that the flowering has gotten earlier, and again, with lots of variations. So what does this all mean, really? How much warmer is it going to get? How much is it going to change? Well, winters in both Wales and the UK are slowly, seemingly kind of getting warmer. And it's only a tiny, tiny bit each year, but that is making a massive difference. And I can see someone in the chat already saying we're in Scotland and ours have flowered. And then someone in Wales saying none of our bulbs have flowered yet this year. And so you can see across the country the variations going on. And again, it's because you will see, oh, we can't see any graphics, I'm not sure. Can anyone see the graphics? No? Yes? I'm not sure if it might have slowed down for you in the chat. Other people are saying, yes, we can see, we can see. So I'm not sure if it might have been a delay or something on your end. I'm not sure. Hopefully others can see it anyway. Yeah, I think we can see. I can see myself anyway. Wait a sec now. I'll wait for till you type Merchants of Venice and see what problem you're experiencing. But yeah, the UK overall are having winters around 0.5 degree warmer every 10 years. So our kind of data is showing that the winters in Wales are getting more and more progressively warmer every 10 years or so. Tiny amounts. But that tiny, tiny amount can make a massive, massive difference. So if we look at how, I'll try to move my head here, how much earlier the plants are growing. So the plants are growing, the crocuses are flowering about 0.49 days earlier every year. So every decade, they're going to be coming out earlier by about 5 days. And then if we look at the daffodils as well, the daffodils are going to be coming out every decade or so. We're going to be seeing them start to come earlier and start to develop earlier. And so, yeah, it is a very kind of unique thing. Or you can see me, but not the graphics. I'm not sure why. I should be standing out with the graphics behind me, so I'm not too sure why that's happening. Teams is a law unto itself. Whenever I start these meetings, I always think everything's planned and sorted, but everything always goes wrong in some way. So you are sharing my going wrongness, but hopefully you're understanding and getting a lot of the information that you need anyway. The graphics will help, obviously, but hopefully you're getting it all anyway. All of this will add up over time. So every few years we get a different decade, and small temperature changes will make a massive impact on nature more than anything and wildlife. So what we can learn mainly from the Spring Bulbs project so far is the warmer winters, the warm in temperature are actually confusing kind of nature. So the plants are not sure when to, start growing or when not to grow and all that. So flowers are blooming earlier, animals are waking from hibernation too soon, rivers dry out because of drought periods and stuff like that. Storms happen more frequently. So there are lots and lots of changes that will affect our lives as well. Like all of these will affect, where our food comes from, where our water comes from, how easy we can travel and how safely we can travel. So if the change keeps going on, every 10 years or more, and it might not seem like, that immediate a threat, but it very much is, and the work that you guys have done has demonstrated that there is a problem more than anything. There is a massive problem. So the coldest places in the world as well will warm the fastest. So the Antarctic and the Arctic just this week released information that the sea ice melting earlier has led to a massive decline in emperor penguin chicks. And so because they're losing ice platforms that they need to swim, they are becoming less and less. And so, yeah, it's affecting the extreme parts of the planet, more extreme, but all of those, but everywhere is going to be affected essentially. Now, obviously 20 years of Spring Bulbs will bring one massive thing, and that's a big thank you to all of you guys and anyone who's taken part in the Spring Bulb project over the years, because the work you've done, I wouldn't have been able to speak for the last 5-10 minutes about anything if you guys hadn't done this scientific work over the years. If you hadn't, logged all your temperatures and growing patterns, all of this information comes directly from all of you guys. And we are massively thankful, we at Amgueddfa Cymru and our partners at Adina Trust are massively thankful for all of you hard work. But there's one last thing I say. Next week, our final session, all of that information we had, we know that the climate is getting warmer and there's climate change happening. And we know that we're doing a lot in terms of changing how electricity is developed and created, but we can do more. So next week's session, we're going to go through some steps to find out what you and your schools can actually do to make a positive impact on climate change. So next week, we are going to create climate pledges for yourself and for the school, promises that we will make to try and change the climate for the better. And so in preparation for all of you teachers listening, I will be emailing the document you see on screen out after the presentation. And all you need to do is either print this out or digitally have it accessible for your pupils next week. And we will be going through this and lots of other information to try and see how we can reduce carbon in the atmosphere and make a positive impact on climate change. But anyway, I have talked far too much already. When I email you out, there'll be a feedback form as well. It'd be greatly appreciated if you could let me know, give me some feedback on everything. That would be great. Thank you very much, Meg, for being my guinea pig with the questions. And Meg will be an even bigger guinea pig next week when we do this session. But I hope you've enjoyed today's session. If you missed anything or if you haven't had joy with the graphics or anything, then I will upload the presentation afterwards and you might be able to catch up that way. Hopefully the screen recording has recorded all the slides. But thank you very much for taking part today and contributing, and hopefully I will see you all next week for another session, our final Spring Bulbs virtual session. So diolch yn fawr everyone and hwyl fawr for now. Thank you.